So hopefully everybody can hear. If not, scream or send something in the chat. So thanks everybody for joining. This is a session organized by the Standing Panel on Impact Assessment of the CJR, which I serve as a panel member on. And we thought it would be really nice to organize a session on RCTs in agriculture, seeing that a lot of the RCTs that we're seeing being done in agriculture are getting a lot more involved, whether that be more complicated forms of measurement or deeper questions about theoretical models, or linking RCTs to theoretical models, or looking more at general equilibrium effects. And so given that there's a lot of interesting stuff being done in this space, we wanted to organize a session to showcase some of that stuff. And so what we're going to try and do is keep to 30 minutes per paper, which is split across three papers. And we're going to start with Jenny Aker from Tufts University, colleague of mine. So Jenny, if you could go ahead and queue up, we'll try and rock and roll here. And I'll of course be the timekeeper.
Great. So thanks everyone for, thanks first of all, SPIA, for organizing this session, and thanks for the opportunity to present. This is joint work with Kelsey Jack at the University of California in Santa Barbara, and with our partners, the Ministry of Environment and Sahel Consulting in Niger. And overall, kind of our motivation for this was just basically the observation that we've seen agricultural yields more than double in many countries throughout the world over the course few decades, but really in many places in sub-Saharan Africa, they've stagnated. And obviously there are a number of reasons for this, but one of the issues that is often put forth is kind of soil quality and land quality. It's estimated, but these statistics are quite old, that about half of the land in the Sahel, which is that band in between the Sahara and the coast, suffers from poor soil fertility. You can see this to the right-hand side, that brown band in between the desert and the coast. And the way in which a number of farmers in these countries have dealt with this is via extensification, right? So using small amounts of labor and inputs as compared to the land under cultivation. The issue has been that over the course of the past few decades, the combination of high population density and climate variability has meant that farmers have had shorter fallow periods, and then that's just made less arable land available. And so what's required then for these sustained yields improvements, especially in these areas of the world, is agricultural practices that do two things, which is one, increase the level and duration of water in the soil, and two, replenish soil nutrients. Now, there's a number of ways and that can be done. I'm not going to address those different ways, but the one kind of body of techniques I will refer to is these rainwater harvesting techniques. These are kind of micro catchments that can be built within your own plot of land. And what they're designed to do is really, when it rains, they kind of capture that soil runoff and they replenish many of these soil nutrients. There are about 70 different types of rainwater harvesting techniques throughout sub-Saharan Africa. Some of them are indigenous. You can see them here, but the ones that we're going to be focusing on for a number of reasons is one called the Demuluns, which means a half moon in French. And kind of the main characteristic of these techniques is there's a main upfront cost, which is labor for construction, and then these benefits accrue over time. Now we're going to be focusing on the Demuluns. I would love to go into all of the agronomic and environmental details of these, but let me just give you some of the snapshots of the things that I think are the most important. The first is that they're going to be really appropriate for severely degraded land, which is called a glacis. And you can see this picture to the right, which basically the non-green part, the tan part, which means it's been completely leached of all soil nutrients. So nothing grows here. If you own this land, nothing grows, not even grassland, because it's been completely degraded. And so something needs to be done to recuperate it, and fertilizers aren't going to cut it. The dimensions vary, but kind of the norms that are often put forth by the ministry and other international organizations are about 250 to 300 demuluns per hectare. That can be quite significant if you think that you can construct about 3 demuluns per day. And they can be constructed during the off-season, the off-agricultural season, which means that they don't compete with agricultural labor, but they may compete with labor for kind of seasonal migration. You can then use them to plant crops in and around them, which is the whole purpose once they start to kind of recuperate many of these soil nutrients. And the previous cost based upon agronomic trials was about $80 per hectare. That's about 30 cents per demilune. But the thing here is that once you've constructed them, they last for 3 years, they require very little maintenance. And by the end of the 3 years, kind of the land in and directly around the demilunes should have been recuperated. And then you could potentially construct new demilunes in between if you wanted to recuperate that entire plot of land. So kind of previous work on agronomic trials suggests that basically using these techniques can reduce soil erosion, reduce the risk of crop failure, and increase yields and profits by about threefold once you add on some other complementary inputs. And there's been kind of decades of investment by international organizations and governments to really promote demilunes, mainly on kind of common land or pasture land. And despite all of these initiatives and kind of what seems to be kind of a profitable technology, the adoption remains low. We're focusing on Niger in this study, where less than 10% of farmers are using these techniques on any part of their land. And the question really is why? We've done some previous work in a pilot that suggested that there was a combination of information, liquidity constraints, and then kind of high discount rates as well, given the fact that the costs are upfront and benefits are primarily after 2 or 3 years. And so what we've done kind of in order to answer this question of, the seeming puzzle about, if this technology is seemingly profitable, why is the adoption so low, given the fact that this land is kind of completely unproductive? We've used a Behavioural RCT designed to relax many of the adoption constraints that we identified. And basically there's one control and 4 treatments. All of the treatments have a training component because we really felt that the information constraint was crucial. But the other kind of 3 interventions have a type of financial incentive component. And they're each quite different depending upon kind of the constraint that we're looking at. The first one is an unconditional cash transfer early, which are paid before the actual construction of demilunes, designed to address a liquidity constraint. Then there's a conditional cash transfer after you construct them, kind of addressing kind of the issue of the time profile of costs and benefits. And given the difference in timing between UCT and CCT and modality, we also had an unconditional cash transfer late, which you got basically after the demilunes were constructed. So we have 1 year of intervention and 4 years of follow-up. And basically what we find is that all of these treatments increase the kind of adoption along the extensive margin. So 95% of farmers in treated villages adopted at least 1 demilune. So training really seemed to drive adoption along this margin. If you look at the intensive margin of adoption, though, kind of farmers in treated villages were adopting about 35 more demilunes in the first year. It was relatively higher in 2 of the financial incentive treatments for the first year. But by the time you get to the 3rd year, these treatments all converge. So they're adopting at about the same level. There are modest increases in adoption over time and then spillovers on neighbors within villages. And the way in which they're adopting these demilunes is really reallocating their family labor. So they're less likely to sell family labor in the off season and more likely to invest that into constructing demilunes. And then kind of these demilunes are associated with impacts on downstream outcomes in terms of ag production, revenues, asset ownership, and soil quality. We then look at kind of some explanations as to why this training alone might be so effective in really spurring adoption along these 2 margins. So in terms of kind of where we're focusing on, for those of you who aren't familiar with Niger, we're mainly focusing on the Zander region, which is completely to the east. It's simultaneously the breadbasket, but also suffers from high rates of soil degradation. And we focused mainly on 180 villages where the key criteria is that they have degraded soil of this type. We did a listing exercise of all eligible farmers, which was about, and then we randomly chose about 16 of them, stratified by gender. So that gives us about 2,800 households. The clear criteria here was that you just had to have some degraded land with a minimum of about 1/2 hectare going up to about 5 hectares, although some of them have slightly more. We did an RCT, and I can talk a little bit more about that in the Q&A, but just to give you a sense of the timing and the rollout, we did this listing exercise of all eligible individuals, basically going back 4 years ago, and then we randomly chose a subset of them and then interviewed them in our baseline survey. And then we did the training. And remember, the training was done with all of the treatment households. Just a few things to note about the training in order to interpret the results and to think about how this might be different from some other trainings. First of all, there was a theory and practice component. You can see here that the Ministry of Environment talked about kind of how Demuluns were done and why they were important. But then also there was a practice. So you got together with the other 16 members or 15 members and constructed 3 Demuluns that day. Then there was a book that was distributed here. It's in French, but it was given in Hausa with pictures along with it that people were able to keep as a reference for them after they left the training. Third, we really emphasized that Demuluns were appropriate for private land, not just common land. Previous trainings by the ministries and the NGOs were done in a way that they were done on common land or pasture land with the hopes that once people did this on this common land, that would spill over to their private land. And then finally, emphasizing the fact that locally available tools then can be used. You don't necessarily need to wait for an external organization to provide a tool, a shovel, a pickaxe. So once the trainings were announced, finished, then the transfers were announced, the financial transfers were announced in all of the financial transfer villages. And then about a month later, the unconditional transfer early was paid out, about $20. So that's about a quarter of what was estimated for kind of the total costs, but based upon some of our pilot work as well. And then about 2 months later, after we did a verification, we paid out the UCT late, which was about the same as the UCT early, a little bit more for interest, and the conditional cash transfer, which gave people about 40 cents for every Demulun constructed of acceptable quality. And the UCTs and the CCTs were basically calibrated to be similar. We then went back in and did verifications every single year, and then did kind of a household survey for a midline and a follow-up in 2019 and 21. And I'll be using kind of data from all of those results. So because we did an RCT, we obviously did a balance table. Things are generally balanced. I just want to tell you a little bit more about this population, which is that they have about 4.5 adult household members. They're owning 4 hectares of land, and about half of those are degraded. And about 60% of that degraded land is this glacis. So again, this severely degraded land that needs some kind of outside input or technique in order to recuperate it. The one thing that was kind of imbalanced is this idea of Demulun experience. So you note here that a third of people stated that they had Demulun experience. And I want to emphasize here that that's on private land, but actually the majority of this was, did you participate in a government or an NGO project where potentially you were hired as labor to construct Demuluns on a common plot of land? There's some imbalance there, which we address through ANCOVA specifications. So basically all we're doing is regressing a number of these outcomes that I'll talk about on a binary variable for each one of these right-hand side treatments. So it's the ITT, based upon our randomization strategy, we use stratification fixed effects as well as kind of control for the vector of listing covariates. And then we correct our standard errors by clustering at the village level, and then also kind of do some robustness checks with bootstrapping. Most of the regressions I'm going to be showing you are cross-sectional. We do some pooled data as well and add in a time fixed effect. So the main outcomes we're going to be focusing on are adoption, and then these downstream outcomes, talking a little bit about labor and kind of what might explain the results that we actually see. So in terms of adoption, as I said previously, just looking at the extensive margin, households in the control group, basically 4% of them tried 1 Demulun during the first year. And then basically in the treatment group, they got up to about 95% of all treated households tried at least 1 Demulun. There's not a statistically significant difference between these treatments. In terms of the intensive margin of adoption, again, in the first year, here I'm showing unconditional measures, right? So basically imputing a 0 value if you didn't adopt that first year. What we can see is in the control group, you tried 1 Demulun. If you're in the training group only, you tried about 28 additional Demuluns as compared to the control. And then there's a slightly higher level of adoption in the UCT early and the CCT groups that first year, about 25 to 40% more as compared with the training alone. If you look at the treatment groups overall, they're adopting about 35 additional Demuluns, and heterogeneous effects suggest that this is higher in one district. We can talk about kind of why that might be, and slightly higher for men, but only about 4 additional Demuluns for men, kind of male recipients as compared with female, which is kind of not as big as a difference as we were expecting, given kind of associated difficulties with accessing labor and credit for women and based upon our pilot results. One of the things we might be interested in is understanding whether or not the CCT group was potentially constructing many Demuluns in the hopes of kind of earning more income. But what we find is that the quality ratio, which is just basically kind of the number of Demuluns that follow the technical norms as compared with the total number of Demuluns, is similar across all these groups. And then we have different measures for adoption per hectare, conditional adoption, and the correlates. So then over time, what does this actually look like? Well, the extensive margin, unsurprisingly, doesn't really change very much in the treatment group because it was already really high. In the control group, it moves from about kind of 4% in the first year up to about 17% by the third year, although this doesn't seem to be correlated with distance to kind of a treatment village. But the interesting thing is the intensive margin of adoption. So there is additional adoption in these treatment villages over time, about 3 to 5 additional Demuluns per year. But more importantly, what we see is that basically kind of all of the treatments converge. So they're basically at the same level by the third year. And I think kind of what is interesting is that then again, they seem to be using these quite intensely. So 90% of treatment households have operational Demuluns. What does that really mean? Since you didn't have to do very much, what it means is that they're adding in manure, they're still planting in and around these Demuluns. So they're intensively using them over time. And then by the time we get to the third year, they're basically adopting between 40 or 50 Demuluns per hectare of degraded land. So I'll come back to that a little bit at the end. So what does this mean for kind of other outcomes that we might care about? Agricultural output, land quality. And what we see is that it has no real impact on what you've decided to plant or sell in columns 1 and 5, either in the short or the medium term. In the short term, it seems to reduce the likelihood of crop failures, but that doesn't persist in the medium term or the longer term. What is important is the kind of impacts on production and also the value of that production. We see in the short term, it increases kind of the Z-score of production of crops by about 0.14 standard deviations. That increases to 0.17 in the medium term. And kind of the impact on the value of production is relatively stable in the short and the medium term. That mainly comes by increases in sorghum, millet, and sesame, which are the major staple food and cash crops. And concretely, what this means is that farmers are producing about 100 kilograms more at a value of about $40 more per year. So after that initial investment. It also seems to be associated with like improvements in land use and quality. I'm just showing you some self-reported measures here, but we do have some more objective and observable measures where farmers are reporting kind of improvements in soil quality, vegetation, and water retention, and they're less likely to report kind of different soil degradation and reduction in vegetation. And so by the end of the third year, what we see is that farmers are cultivating about a third more of a hectare, which kind of corresponds to the adoption levels that we basically see. Now, how are they kind of making this happen? What inputs are they kind of using? And as we said previously, the main cost is going to be labor, very small kind of cost for other inputs. And what they're spending is about $15 on constructing these Demuluns using a combination of family and non-family labor. There isn't a statistically significant difference in the amount spent between these treatments. And what they're basically doing is reallocating their family labor. So they're less likely to sell it, either kind of within the area or for kind of seasonal migration, not kind of major increases, but kind of it's statistically significant. And then they're using this to basically construct Demuluns. They're also more likely to hire outside labor for non-Demulun purposes in the short and the medium term, which would kind of make sense if we think about how they are then kind of planting and harvesting that additional land that they are now cultivating. They're also adding in other complementary inputs in terms of manure and other types of tools such as pickaxes and shovels. So in terms of the cost
3 minutes,
benefit,
Jenny, if okay. Sorry, 3 minutes,
okay.
Jenny, or so. Thanks.
Yep. All right. So basically the costs, kind of a back of the envelope, is about $30 if we just basically add in anything. The revenues are kind of $40 per year. And then we also see some complementary kind of revenues or benefits as well. But as we said before, if we look at kind of our measures, we see that adoption per hectare of degraded land is about a fifth of those recommended norms. And so the last two things I just wanted to end up on are basically, okay, kind of why are these levels below full adoption? And secondly, why was the training so effective? So there's a number of things that we could discuss here, maybe in the Q&A. The thing that I'm going to be landing on in terms of why are these levels below full adoption is A, kind of the measurement of degraded glassy land, kind of how we measured that in the beginning. And then when we did an updating for that, we basically find that farmers are adopting about 48% of the kind of the ministry's level. That's still below full adoption. And the last one is some kind of evidence of behavioral frictions, which we tried to address with a a nudging experiment in the 4th year. And I can talk about some of those results in the Q&A. For the training itself, we were really interested in kind of the different mechanisms through which the training could affect adoption. It was just, you know that they exist, you're getting technical advice, you're persuaded, there's a social component, or maybe there was kind of some outside nudging. We don't think it's really kind of the fact that, you now know that these Demuluns exist, given kind of the high rate of people hearing about Demuluns. But the two things that we think were really important here was the fact that it gave technical advice and the social component. So while kind of the level of knowledge was high in the control group about Demuluns and kind of some general technical issues, what we see here was the results of a test show us that people really improved their knowledge in the treatment group about kind of the things that really matter in terms of constructing Demuluns, constructing well, and improving their impacts. And here it was kind of the number of Demuluns, spacing, dimension, and depth. If you do these things wrong, the Demuluns aren't necessarily going to work or work as well, and they could potentially be harmful. The second area where we saw some kind of effects was this idea of social learning, and this is kind of within village spillovers. We have two different measures of that, basically kind of looking at your neighbor's plot of land, but also we have a spillover sample that was taken from our listing exercise. And what we see here is that the extensive margin of adoption increased for both these two groups, as did the intensive margin of adoption, which suggests that there was kind of some learning that was going with the fourth. That in addition to the fact that you were kind of contributing potentially to helping out on other neighbors' land. So kind of our key takeaway here is that this seems to be kind of, as we said, it can be quite expensive per hectare, but here they were spending about $30 for the initial construction, and they have the potential to help kind of farmers mitigate these impacts of soil degradation. Training alone seemed to be sufficient and cost effective, and the spillovers really suggest that learning from others is feasible with this technology on private land. What we're doing now is using remote sensing measures to help us kind of get better impacts of productivity and diffusion over time. And I'm happy to talk a little bit more about kind of the advantages and disadvantages of that, and then work with the ministry to try and scale this up in the rest of the country. So thank you.
Thanks, Jenny. So Lorenzo's already onto the screen share.
Great.
Just a second. Sorry, Lorenzo, before you start, does everybody see Lorenzo's screen completely, or do they see a partial screen?
Partial.
Yeah. Let's see, maybe if you try sharing that again, Lorenzo. Yeah, there we go.
Yeah. Okay. The unshare and reshare by sophisticated.
Yes, just like the restart
great.
On the computer, Lorenzo.
So good morning, I guess, for you. Thanks very much for having me and for allowing me to discuss Jenny and Kelsey's paper. I really enjoyed it. So I will, very briefly summarize the results and then provide a few comments. So, very speaking, the contribution of the paper is to run very well and very persuasively a village-level RCT on agricultural soil conservation, and it's an experiment that looks both at adoption determinants in its design and at impact of adopting this technology. So obviously, soil conservation is a critical issue for African agriculture due to climate change, population growth, etc. But it's also an issue in which there isn't much experimental work. So in this sense, as I'm sure the authors are aware, this is a very welcome contribution. And then, the specific technology they focus on is relatively low cost, relatively easy to adopt compared to other, of course, preservation mechanisms, and so it's potentially scalable. And indeed, I'm very happy to hear that now they are working with the government to scale up based on the results of this intervention. So, main results: the training, the unconditional cash transfer, and the conditional cash transfer have a roughly similar large impact on technology adoption. And the training does seem to increase knowledge of how to use the Demuluns and of the benefits of this technology. There is a sizable impact on output, 0.15 standard deviation, so quite large, and a very large cost effectiveness. Okay, so these are the key things that you should remember from the paper. So I have four main comments. So the first one is that the fact that this is a seemingly profitable technology opens up a puzzle of why, in spite of the fact that this technology has existed for a long time, adoption is still very low. And at least in the introduction, I think there is a reference to the fact that there is a gap, as in many technology adoption problems, between the timing of the cost and the timing of the benefits. And benefits, at least ex ante, are supposed to come only 2 or 3 years. And so if that's the case, then obviously there is a large role for things like liquidity constraints, discount rates, etc. Now, in practice, and Jenny, correct me if I'm wrong, when you then go to the data, it does seem that some of the benefits are realized quite quickly, for instance, in terms of output production. So they have 4 years of data collection. This is a pretty impressive data collection strategy. I understand they're doing now follow-up experiments, but basically they ran the intervention in 2018. Sorry, I don't know the exact season calendar, but so I'm referring to the calendar years. So they ran basically a baseline survey in early 2018, and then in the mid of 2018, they do the interventions, the training, etc. And so the midline survey is basically run within, I don't know, 9 months, or basically after, I think, 1 season of the experiment, correct me if I'm wrong, and you already see this impact coming up. Okay? So it appears that benefits after the first year are roughly equal to the benefits after the 3rd year. But now, if anything, this seems to deepen the puzzle of adoption, right? Relative to a scenario where you say, oh, the benefits only come 3 years after investment. But on the other hand, the fact that the benefits are immediate, maybe ex ante, may suggest that things like liquidity constraints or discount rates, impatience, whatever, are a bit less important than in this other scenario. Okay, so maybe from this perspective, it's not completely surprising, and then things like the conditional anchor transfers or the exact timing of the conditional anchor transfers don't matter too much in addition to the training. And indeed, the big and striking result of the paper is that training alone, a very well done training, has a large effect on adoption. And I will come back to this, but I should highlight that this is particularly interesting results, given that the literature on training agriculture is large and very, very mixed. Let me put it this way. I don't know many papers where training alone has such a large impact on adoption, basically. From nobody, although, sorry, I meant to have the extensive margin, but basically from 2% to 95%, and it's not just a peanut trial in the treatment. They don't do, of course, 100%, but they do 40% or so. So it's a large amount of experimentation of trials. And so the big question that I think the authors are trying to dig more is why exactly this training is so effective. And so on the one hand, I think they do push the fact that the training did increase knowledge, if you refer to these items that already in the slides were highlighted. And here I have a bit of mixed feelings. And so, Jenny, I'm very interested in your response to this. Because so it's true that they know that the number of Demuluns have to be very large, but the number of Demuluns that they actually build is still, again, a third, 40%. And one implication is that given that the number is so much smaller than the recommended one, knowing about the exact spacing should not matter much. Or I'm guessing that the optimal spacing, given that you only do 30%, is very different than the optimal spacing if you were to do 250 Demuluns. Another thing to emphasize is the correct dimensions of Demuluns, but I don't think we have any data on this. So I would like to see some descriptives on, is it the case that not only there are more Demuluns, but they are better in sense of depth and width or whatever it is. Now, just at a quick look, it seems that other aspects of the training are important. So for instance, I was completely surprised, sorry, this reflects my ignorance on a lot of the agronomic stuff, that you can actually plant in a Demulun. So it's not really following in the starkest sense, right? So maybe just knowing about that changed people's mind. You can actually cultivate. And the fact that there are, again, output gains already in the first year suggested maybe a chance. And so I'll come back to this, but I think that explaining what exactly the training works is probably something you can do a bit more. My third point is on the output results. Again, it is interesting they come very, very early on. They seem to be an important extensive margin. They cultivate a larger amount of land, 0.3 hectares. I was wondering if you could go a bit further in telling us about things like yields or TFP measures. So is it the case that now the soil is more productive also, or whatever? But maybe even more importantly, from this nice baseline data, you have information not only on hectareage owned, but on the number of degraded hectares. Sorry, it's a bit blurred, but I guess you can see the table. And I wonder if you have any way to look at output effects separately for two groups. Ideally, you will know which plot is degraded and which plot is not degraded. But even if you don't have that at the individual level, right, you're going to have share of degraded land varying by individuals, and you may do some methodology. But I think shining a bit more light on, is it just they cultivate more, or is there something on productivity? It will be useful. And now, stepping back a second, I think that, and this is just food for thought. I don't have strong views here, but right now the paper is really about this technology of soil conservation, rainwater harvesting, which is clearly super important, and the topic is important for agricultural economists, etc. But at the end of the day, the most striking results are about the training, as opposed to nuances of which type of financial incentive you have to provide, etc. And so maybe, and I emphasize the maybe here, to speak to to an even broader audience, I wonder if you should try to put a bigger effort in relating this to the literature on trading more broadly, not just agriculture, but think about the small farm training, etc. And indeed, so this was not, or I didn't catch that in the slide. It seems that you are trying to do some additional experiments to disentangle exactly which component of the training seems to matter. So that this goes exactly in the direction I was thinking about. I didn't appreciate that from the slides, but yeah, it seems that this, again, relating a bit more to this broader literature on training may make the paper even more valuable for an audience which is even larger. I'll stop here, but again, it was a pleasure to see the slides and looking forward to reading the paper. Thank you.
Thanks so much, Lorenzo. So I think, Jenny, if you wanted to respond to any of that, let's just use the chat and kind of just so we can move along efficiently, if that's okay. And you can also catch up with Lorenzo later offline, I'm sure.
Yeah.
Okay. So then let's go ahead, and I don't see anything in the Q&A or the chat, but I think Jenny will be around for. So I'm gonna take this opportunity to ask this one question that just popped up in the Q&A right as I said that, and then we'll move on, which is from Dario Schultz asking, will you look at permanence, maintenance of old, i.e. maintenance of old or creation of new Demuluns after the 3 years that they remain functional?
Yeah, so that's part of the role of kind of remote sensing that we want to do, right? So the thing about Demuluns is at the end of the 3 years, right, they've recuperated the soil. So you can see that soil is more fertile, though the question is how remote sensing can pick that up. And then our idea with using then remote sensing, since we have all of the geolocations of those plots, is to see then new adoption of Demuluns, which is very easy to disentangle from old adoption, and to see how that disseminates in these areas.
Yeah, one of the nice applications of remote sensing where you can track things for multiple years after you're done in the field. So let's go ahead and move along. Thanks so much, Jenny and Lorenzo. So Florence Condolis from the World Bank Dime is next. And sorry, Jenny, there's several other things that have popped up in the Q&A, and if you could, at your convenience, kind of manage those. So go ahead, Florence.
If you can hear me. So talk about this this that we did years ago and that we're still working out because of my co-author John is so.
Sorry, is Florence choppy for everybody? I think she might be. So let's give it a second, maybe. Zoom does its thing. I think Florence has just come back. Florence, maybe if you could try just using the audio only instead of the video, if it gets questionable to save on bandwidth.
Yeah, sorry about this. I got kicked out.
Yeah, and then you got that awful
this
thing.
Should work now.
Your connection is weak. Go ahead and share your screen first, Florence. I think you're not quite sure yet.
Is that in now?
We're good. Okay. We're good. Go ahead.
Sorry, I was on the wrong network, I think was the problem. Okay, so this is a paper that we're working on with a couple of co-authors. I don't know if you heard that. John is on the chat as well, so feel free to ask questions and he'll answer in real time. So the motivation, we don't need to motivate this research too much. This is within the aim of understanding the adoption of productive technologies in areas that have been sort of bypassed by the Green Revolution, and also cultivations that have been bypassed by that revolution. And so within this spirit, and very aligned with other papers in this session, we want to understand, how do farmers learn about new technologies? Within this literature, which recently has definitely made a big step forward, we know that social learning matters, that the identity of the messenger might matter a lot in kickstarting the process of diffusion of a new technology. We also know that learning from peers may be stronger, that gender may matter. So there's a lot in this literature to unpack about the mechanisms that underlie this learning. So I think a lot of the literature is trying to take social learning and experiential learning quite seriously, so as to say something about the optimal design of the introduction of these new technologies. For example, who should demonstrate a new technology, how many farmers should demonstrate that technology becomes quite salient when we think about these questions. So in this study, the research questions we're going to pose are, what's the optimal allocation of demonstration resources given a fixed allocation of these demonstration resources? And so, for example, should all the demonstration resources go to one farmer, or should we spread these resources across many farmers in a village or a group? And so to contribute evidence to these questions, we designed and implemented a field experiment with the Bangladeshi Agricultural Extension Services to demonstrate a new flood-resistant variety for crops that were bypassed locally by the Green Revolution. And so that's going to be basically everything except for paddy. We're going to randomly vary the number of experimenters that get these resources and these demonstration resources across villages to learn about the optimal allocation of demonstration resources under this fixed allocation. And while answering this question in and of itself is going to be super important for agricultural policy, we want to know how to get more people to adopt a technology that seems to be profitable for some. We also want to shed light on the underlying mechanisms of learning, and particularly what is the relative role of learning from experience versus learning from others. And to do this, what we're going to do is along the lines that Jenny proposed, leveraging 4 years of post-intervention data to study the dynamics of this technology adoption. We're going to ask, can we learn something from changes across treatment and control and across treatment arms over this study period? So what are going to be the key takeaways very quickly in the medium run? 1 year after the end of the first demonstration season, we're going to find that demonstration increases the adoption of these improved seeds quite substantially. And that increasing the number of demonstrators in the medium run is also going to really boost this adoption in excess of what we see in the other treatment arms by 6 percentage points. So that's quite large. In the long run, however, after 2 years after the end of this first demonstration season, we're going to find that the impact of demonstration in the pooled arm, when we pull across treatment, goes down a bit to 3 percentage points, but also that this advantage, this excess adoption that we got by increasing the number of demonstration is going to really vanish. And so what we're gonna conclude is that the optimal mode of demonstration will depend a little bit on the time horizon we consider. We're gonna then go into the mechanism and discuss a little bit what we think is going on. But what's going to be interesting, I think, and this is something we're trying to push on, is that the number of demonstrators is not going to affect the number of adopters, nor going to change the characteristics of these adopters in the long run. And so we're going to find that it's sort of the same set of farmers who are going to eventually learn to adopt this new technology across different modes of demonstration, which is kind of kind of highlight the fact that, of course, there is learning, but there's also learning about, your own returns to this technology that kicks in. And so even if you kind of speed up the learning among many, you may not fall back on your feet with more adoption in the long run, which is sort of logical and nice to see. So what's the intervention? So this project was done under the auspices of a large World Bank investment in Bangladesh, where the Ministry of Agriculture was promoting newly developed flood-tolerant varieties of borrow season crops to improve resilience in the Behavioural district of Bangladesh. So this is really a district that's extremely prone to floods. And this is kind of bizarre. We're studying flood-tolerant crops in the dry season, but this is because this flood tolerance is particularly important at the onset of the monsoon, where there's a lot of floods. These areas really get hit by that. And so to promote these crops in this area, you really need a variety that's gonna be resistant to a high level of salinity. And so the 5 promoted crops, which are mung, wheat, mustard, lentils, and sesame, are also going to be picked because in this area of Bangladesh, the use of irrigation in the dry season, particularly for paddy cultivation, this is the very contentious 3rd paddy season in Bangladesh, are really depleting the water tables and sort of, creating a lot of increased salinity in the water tables as they rise. And so this is something that the government is also interested in doing, is promoting crops that lower the reliance on dry season irrigation. So in each village, we're going to have a demonstration package that's going to consist of improved seeds for about ½ hectare of land. This is the average land size in the study sample. And this is, just to highlight, this is really the first generation of improved seeds for these crops in Behavioural. These crops were completely bypassed by the Green Revolution in Bangladesh. The demonstration packages are provided through farmers groups. So this, you have to think about 25 farmers who are quite tightly connected. So this is a dense network of farmers. We're not going to think about a context where you have a lot of sparse connection. These farmers know each other very well. They work together. So this is important to sort of interpret the results that are going to come next. So what's the experiment we run? We compare 3 types of demonstrations across 1 or 2 villages in Behavioural. We're going to randomly assign 25 of these villages to what we call a regular demonstration, where 1 farmer is going to demonstrate with the entire packet of demonstration on their plot. This is really the statu quo for these extension services when they do demonstration. This is how they do them. I think this is quite comparable to what you see with farmer promoters in a lot of countries, especially in Sub-Saharan Africa, where I'm more familiar. Then we're gonna assign 25 villages to what we call a shared demonstration village. Here, the effort was to find 4 farmers within these groups who were cultivating contiguous plots and could share the demonstration across the corner of these plots. This way, we could kind of manage how many people were learning about the technologies while managing also the area under that cultivation. And then we have 25 randomly selected villages that are assigned to self-demonstration. In these villages, all interested farmers can demonstrate on a small portion of their land, so the package gets split again between these farmers. And then we have 27 control villages, which are not going to receive anything. But of course, all these villages are under the auspices of this large project. And so finding the effect of demonstration, this is really in excess of a lot of other things that are happening in the project, particularly maintaining a market for these seeds. So I want to make that clear also. It's quite important. There's really an effort for seed multipliers to carry these seeds to the market, and the government is extremely has invested a lot in that, and we have a lot of evidence that that's happened. So what do we have? We have a baseline survey that we ran many years ago. 1 year later, we do a first follow-up. So this first follow-up is going to be basically the result of this first demonstration season. Then we have a midline 2, which is 1 year after the demonstration season ends, covering the first true adoption year. And then another survey that we're going to call our endline, which happens 2 years after demonstration season ends, covering the second adoption year. Within these villages, our sample is going to consist of all of the 25 farmers who are in the groups. We collect plot level information on their farming and crop choices and production on their main 2 plots. Now, we we basically ask about these two plots, but we're going to do a lot of robustness check where we're also going to verify that this does not introduce bias by showing results on selected outcomes that are available on all plots, and we're not going to find that this affects our findings, but this is something we have here with a button in the appendix if you're interested. So we're going to start by pooling across treatment and just asking, you know, did demonstration do anything across all these treatments? So the empirical strategy here is going to be restricting our analysis to what we call shadow crops for power. What do we mean by that? So what's a shadow crop? It's not a fantastic name, so we're looking for a better name. But in the treatment, these shadow crops are the crops selected for demonstration by the extension officer. So there's quite a bit of discussion about the suitability, the local suitability of different crops. So this is what we restrict our analysis to. In the control, we use the crop selected for demonstration by the extension officer in a treated village that's in the same union. So that's a small administrative level. And in our sample, we have 2 villages per union. So this may be an issue. You could think of, you know, this introducing biases. If we have village level shocks to crops that introduce selection into being demonstrated, we're going to do some robustness on that. We show that there are no baseline impacts on outcomes for shadow crops. So the shock must have occurred after baseline and before demonstration to bias our results. And so we're going to find comfort in that. We're going to show also that there are no impacts on non-shadow crops as a placebo. So this is something we provide for each of the results. We also look at basically a placebo effect in the non-shadow crops. We're going to find no impacts, but also this is also going to serve as a test for mechanisms that are unrelated to learning. So we can think of, okay, we give this little package, maybe, you know, that's an income shock. Maybe there are other within household spillovers of this, you know, demonstration effort, and we're going to find no impact on these other kind of non-shadow crops, which is going to give us some comfort that what we're looking at is a learning effect here. We also find that there are no differences on average in the crops selected across modes of demonstration across the different arms. So that's also going to give us some comfort that we are not looking at something that we're not introducing bias in our design. So what's the estimation strategy? Very simple here. In the pooled analysis, we're going to compare within crop outcomes across treatment and control villages, restricting to these shadow crops. And we're going to estimate these impacts in the baseline, which is our placebo year, the midline 1 for short-run demonstration effects, basically, and then midline 2 and end line for the medium and long run. And we're going to cluster our standard errors at the village level. We're also, because we have small numbers of clusters, doing randomization inference. We're not presenting the results here today. Typically, this is going to add precision to these conclusions. So what do we find? We find that demonstration increases adoption of improved seed in the medium and long run. The key points here are that we estimate these impacts on both the extensive margin. So this is the left-hand side panel. This is, are we seeing adoption at all, any adoption by farmers in the group, and at the intensive margin of adoption, which is how many hectares of land are under cultivation. Now, I want to note that for the midline 1, oh, actually, no, never mind. So these are, in the midline 1, what you see is just the impact of having distributed this demonstration. Demonstration is ongoing. In the midline 2, that demonstration stops. So midline 2 and line, these are pure adoption results. What we find is that and I want to say all these outcomes are going to be unconditional on cultivation, of course, since we're affecting farmers' decisions about, you know, whether to adopt these crops or not. And so what we find is demonstration worked to the extent that we have a 14 percentage point increase in midline 1 adoption of any improved seeds. But this impact falls by 6 percentage points by midline 2. So there's no more demonstration. So we interpret this result as reflecting some persistent learning impacts from the first demonstration year. We also find some striking patterns on knowledge score. Sorry, they're not reported here for brevity, that corroborate the notion that these differences in learning across treatment and control underlie these differences in adoption. And so we find a 12 percentage point increase in the knowledge score in the treatment relative to control by midline 2, and these are very precisely estimated. These impacts are going to fall to 3 percentage point by end line. So we'll revisit this result and provide evidence that this is a positive impact that reflects persistent learning, while the decrease in impact reflects selective disadoption of this technology. So this is nice. We find sort of a long-run impact of demonstration. So demonstration seems to have persistence impact. And this is even in a context where there is a huge investment by the government in making these, these crops work for farmers. And so this is, we think, quite striking. So now that we've seen this, we can ask, so what is the optimal allocation of these demonstration resources if this works quite well? So then what do we estimate? Similar.
Florence, about 3 minutes, if that's okay.
Okay. All right, perfect. Wow. So we're going to run the same sort of specification here, but now splitting across the different treatment groups. And what we're going to find is that having additional demonstrators is going to increase medium run adoption quite strikingly. So beyond, so the midline 2 here that you see both at the intensive and extensive margins of adoption. But that these effects are going to vanish. So this advantage of having more demonstrators is sort of going to vanish in the longer run. We're also going to find, so when we look at results in our knowledge score, we're going to see that the knowledge effect is quite large in midline 2 for villages that had more adopters, and we're still unpacking the results on this learning in the long run. But so it seems like in the longer run, farmers are going to learn about their type. They're going to learn whether this technology is working for them, and there could be sort of convergence in learning across these arms, which is, I think, also something that Jenny highlights is quite interesting. So the big question here is, do the same levels of adoption across the different treatment arms by end line correspond to different sets of adopters? So we're going to do some complier analysis to look at this. We looked at a different set of household characteristics, but the one that really sort of stuck is that the adopters by end line were more likely to have cultivated non-paddy borrow crops at baseline than the adopters in the control. So there seems to be selection into adoption that's along those lines in all our treatments, and that selection is being applied quite similarly across treatments. So this seems that across all these different types of demonstration, the number of demonstrators does not affect the characteristics of adopters by end line. This is consistent with the absence of end line differences in impact of increasing the number of demonstrator adoption. And so it's the same set of farmers that finally adopt this technology. So this is quite interesting, we think, and we're going to keep pushing in that direction in a future version of these results. So yeah, just to very briefly conclude, we find that demonstration persistently increases adoption of new seed varieties, while increasing the number of demonstrators only temporarily increases adoption. The impacts of alternative approaches to increasing technology adoption can vary meaningfully over time, is what we're learning from this paper. Our results suggest an important role of demonstration in agricultural extension, but we failed to find differences in long-run impacts of alternative modes of demonstration, despite very large medium-run impacts. We provide suggestive evidence that our results are explained by selective adoption driven by learning. In the long run, it's the same farmers who are going to adopt regardless of the mode of demonstrations, but these long-run adopters are different from the experimenters. We note that these conclusions on diffusion may be shaped by the technology we're studying here. This is, flood-tolerant varieties of crops, the context. We have farmers groups that have tightly knit, and so it might, our results suggest that in contexts where benefits of adoption may vary meaningfully across farmers, and where learning networks are sufficiently dense, learning and selection may happen in just a few years. And so while demonstration is necessary to kickstart this process of diffusion, different modes of demonstration may at best accelerate diffusion in the medium run, with things kind of converging in the longer run. So that's, and yeah, that's it. Thank you.
Thanks, Florence. Let me go ahead and queue up here. So I'm actually the discussant for Florence's paper. So let's go ahead and move right along. So let me start by just saying that this is an awesome paper that's near and dear to my heart for a few reasons. One, flood tolerant seeds. 2, demo plots, and then 3, another paper showing multiple follow-ups, a lot of long-term data collection showing us that things can change quite a lot over time, which I think is especially relevant in agriculture. So the main takeaways that I took from the paper is that there are large increases in adoption from demonstration plots, but increasing the number of demonstrators seems to lead to more additional adoption, which fades pretty quickly over time. And so I think this has nice implications for policy in terms of it's better to reach more villages with a smaller number of demonstrators or a single demonstrator rather than increasing the intensity within villages. And so my main suggestions, and I'll try and be brief, is to try and deepen the thought process and the analysis towards, and I think this is where you're going based on my understanding of the paper in terms of the model and sort of tightly contrasting possible mechanisms. So in that spirit, I'll play the role, I guess, of pesky referee to sort of point out what I think are some possibilities here in terms of the model that might rationalize these results. And the first possibility, I think, is the one that, based on my read, is kind of where you're thinking is now, is that increasing the number of demonstrators kind of mechanically in the very short run, at least with the very first follow-up survey, leads to more initial adoption. But then the question is, how selected is that additional adoption? And are these people with relatively lower returns, whereas a single demonstration leads to less but better targeted adoption, which would mean that what we're seeing is just efficient disadoption of people with lower returns over time for these technologies. So I think one thing to do there would be to look at disadoption separately from first-time adoption and sort of separate that out in the data to speak to that distinction a little bit. I think that's something you can probably do with the data at hand. Another thought was that it would be really helpful to know more about the sources of heterogeneity for these particular technologies, these particular flood tolerant seeds. Whether it be like differences in, say, risk aversion across the sample, or differences in flood exposure, which can vary quite a lot even from village to village. But just sort of in terms of the context, what is it that really drives the heterogeneity in returns to these technologies? Is there a lot of heterogeneity which would sort of go along with this story of selective disadoption over time? And so knowing more about that, I think, would be really fantastic. Possibility two, which I think is maybe in my initial read, I maybe put a little bit too much weight on this, but I think there might still be a little bit going on with sort of network-based diffusion of information. The idea here being that when you increase the number of demonstrators, even though it's only a group of 25 people, and you mentioned that it's a very tight-knit group, we don't have a strong sense of what the sort of the network looks like for those 25 people. But increasing the number of demonstrators, might enhance the information cascade, sort of like the Akbarpour et al. Recent paper. And so what that does is just improves information diffusion through the network. But what type of information is it that people get from that more effective information cascade? Is it that they learn to just maybe try this technology, or they learn basic things from this long information cascade? Whereas from this single demonstration plot, big plot right in the middle of the village, they can go there and learn a little bit more type of stuff that helps them make a more long-term adoption decision rather than just to try a technology by themselves. And I think this is probably more a relevant mechanism for the people outside of your sample of 25, to be honest, when I thought about this. This may be more relevant for that group, which I think would have been, maybe you don't have the data, but that was would have been an awesome group to look at. If you do have the data, even better. But my main thought here is that demonstrators, increasing the number of demonstrators might only work better for kind of simple models of contagion through the social network, not necessarily agricultural learning where you have to learn a lot about returns and heterogeneity of returns, and whether these things are relevant for your own conditions on your plots, which is, I think, a much more complex type of learning than sort of the stuff that we see in sort of simple models of contagion. So moving to my third possibility, it wouldn't be a proper AgEcon conference if I didn't mention the inverse productivity puzzle. So my thinking here is that when you increase the number of demonstrators, but you have the same resources, that means that they're going to demonstrate these on smaller plots. And so they're all going to cultivate on much smaller plots, and then the yields are higher on those smaller plots. And so that might send a signal to people that they might should adopt early on, but then they slowly disadopt when the growing season, they start to grow these on normal size plots, and then it sends the appropriate yield signal. So one thing you could do here is look at yields of the demonstrators by the number of demonstrators and see if those yields are higher, to kind of tease out what type of signal people are getting across these different arms, and maybe if it has something to do with the really tiny plots or the smaller plots that were being cultivated when there are more demonstrators. So yeah, I'm gonna skip this slide because I just sort of, and I'll share these with you for free disposal at some point, Florence. But it was just my thoughts on some of the things that might be going on in the model. But I think it might be a bit more weighted, too heavily weighted to the network-based sort of information cascade model, which I think is not quite the right one here. So, and just let me close with a few small things. I think it would be really useful to dig deep into the that's my alarm, the self-selection into who's going to be a demonstrator in the self-villages. Like who said yes and who said no in that very first year. I didn't see a lot on that margin, and I think that's really important, particularly for the main mechanism that I think you have in mind. A couple more before I close. If there's variation in heterogeneity of conditions in these villages, I'm not sure if there is, but in more heterogeneous villages, I think you should see more selection into learning by doing, more people willing to select into being a demonstrator, because you need more demonstrators in those villages to really convey the heterogeneous return. So that's maybe one thing that might be worth looking into. And then I'll just stop after this third one, which I think I kind of already said, but beyond the initial sample of 25, that I think there was probably a lot of interesting stuff to see how they reacted to the increased number of demonstrators in the long run. And I'll stop there because I've already ran over time, but this was really a fun paper to look over, and like I said, all of this is always free disposal.
Thank you so much, Cal. This is fantastic.
Sure.
Thank you.
Sure. So I'm gonna jump back, and if I didn't see, if anything comes up in the Q&A, Florence, I don't see anything now. Oh, sorry. I'm gonna do Nancy's question now, Florence, before we move along, if that's okay. Nancy's asking if N-line adopters tended to cluster within certain producer organizations, or do you have any producer organization control characteristics for those controls?
That's a good question. We haven't looked into that. So my understanding is that these producer organizations in our setting were set up by the project. So these are, those groups. And so, I don't know what we think about, other groups that may exist beyond the scope of these farmer organizations that the project selected. And so that's a good question I can look into, I think in the network section, we should have information on that. So that's a good point. I haven't done that. Thank you, Nancy.
Thanks, Florence. And any other questions that come up in the Q&A, please feel free to handle as you wish, Florence. So let's move along to our last paper, Noreen Karchawala from IFPRI. So Noreen, if you could go ahead and queue up.
Can you guys hear me all right?
Yep, excellent.
Great. We did test this before the session.
Yeah, I can see your screen now. It looked different a second ago. You're clicking through slides. So you're good as far as I can tell.
All right, I'm going to do it this way then. Great.
Okay.
Thanks, Kyle. So this is joint work with Dan Gilligan, who is also on the call and will be managing the chat. Thank you. And we're going to come at some of these questions from a different perspective, which is from a market level perspective, and how some schemes related to adoption can have market level effects. And this is going to be a product assurance scheme, and the evidence is going to be from Uganda. So there's a pretty high prevalence of credence goods in markets in low-income countries. And credence goods are those for which we cannot observe quality ex ante or ex post. So these markets have a lot of information asymmetries. So the basic idea is that there are high and low quality products in the market, but consumers can't tell the difference between the levels of quality between products. So what happens is that their willingness to pay for these products is lower. And because the cost of producing quality is higher for high quality firms, they tend to leave the market. And you have on the market then mostly lower quality products. And this is the market for lemons problem that Akrylov talked about in his seminal paper. And so what you get is a pooling equilibrium where there are low price, low quality products on the market. And firms that produce high quality products don't have a great way to signal quality because price doesn't work in these types of markets. So in this paper, we're going to look specifically at this question in terms of agricultural inputs and specifically hybrid maize. So, don't need to tell this audience, but farming is the main source of income in sub-Saharan Africa, and maize is the second most produced crop. And hybrid maize seed can be very profitable to farmers, but adoption is very low across different contexts. Now, hybrid maize is a credence good. So when you go to the shop and look at a bag of maize seed, it's sometimes difficult to tell whether that's even hybrid maize seed because there is a relatively high prevalence of people taking conventional maize seeds, these unimproved varieties, and masquerading them and selling them as hybrid varieties that are drought resistant, pest resistant, things like that. So this is really harmful for the productivity and incomes of farmers. So in this paper, we're going to study the effects of a price subsidy for a new type of hybrid maize seed, which in itself is a credence good because no one has experience with it before. So the thinking usually behind ag input subsidies is that people need to experience the benefits. And so if we provide subsidies at first, people will adopt the products later on their own. But the evidence here is mixed, and the effects sometimes don't persist. So why is that? And what our thinking is that we don't just need to consider the sort of usual framework there for subsidies, but add a dimension that thinks about quality of products and the observability of the quality of those products. So if there is a low price, low quality equilibrium, then even with a subsidy, people may not want to purchase the product anyway. So the Ugandan government introduced what they call a product assurance scheme, and the scheme was called CACASA, and its aim was to improve the overall quality of agricultural inputs in the market. So what happens is that labels are placed on bags of hybrid maize, and these serve as a signal of quality. And we provide a full subsidy for farmers to purchase these products in randomly selected markets. And this way, farmers can learn about the benefits of the inputs, but also the quality of the inputs. And we examine the effect of this subsidy on consumer and producer behavior, as well as the quality of products available in these markets. So we contribute to the literature in several ways, but we think our most important contribution is to the literature on subsidies, specifically in markets for credence goods and those that have really high returns to poor farmers. And what we show is that additional signals to consumers are needed above just sort of short-term experiences that subsidies often provide. And we, contribute to other literatures on, market effects on these kinds of schemes, agricultural technology adoption, and information asymmetries in markets for credence goods. So here's what the intervention looks like. So I don't know if you can see my cursor, but on the left side of the screen is an example of the CACASA label. And it has a scratch panel, just like sort of phone credit when we go to places like Uganda. And the farmer then can scratch off that panel and it reveals a code. So that's what's here in the middle of the slide. And then what they do is text that code to a short code. So in this case, 114*2, and then the code. And these codes are unique to a specific package. And so once they text that code in, they will receive a text message back saying, this is the variety of this maize seed, this is the package size, and this is the expiry date. So the farmer can then check against what's on the package in front of them and sort of verify that this is what they're actually getting. So the farmer can also report fraudulent products to a hotline, but we need to note that there wasn't that strong enforcement of this. The idea here is that they can do this and they know that they can do this. So on the firm side, a company needed to pay a fixed fee to join CACASA, and then they also needed to pay for each label that they put on their products. Also to note that product assurance is different from quality assurance or standards. The government didn't actually check what the quality was of the labeled products. So this is a different kind of scheme, and I'm going to come back to the implications for this a bit later. So we have a baseline and an end line 3 years apart. We have 120 markets that we can randomize across, and 240 communities that source their inputs from the same market with a sample of more than 2,000 households. So this is sort of the household survey part of our experiment. And then we also conduct a detailed market level survey on prices and quality, where we collected a whole bunch of samples of hybrid maize from shops, and then we tested them for quality. And in this paper, I'm going to focus on germination rates as our measure of quality. So in this context, a couple of things to note is that certain maize varieties and maize companies selected into this scheme. So remember, this is not mandated by the government. Like, you can only sell these products if you pass a certain quality threshold. In product assurance schemes, firms can select whether they opt into it and even what products they decide to label. And so it's really only the companies with higher quality products that they have an incentive to select into this scheme and can afford the cost of the scheme. And that's exactly what we see is when we run a lasso specification on what characteristics predict which firms and which varieties eventually select into the scheme. The only predictor is the quality of the products and the varieties at baseline. And some high quality companies that we know are high quality from studying the quality of products at baseline chose not to label their products. And this is going to be important in interpreting our result. And so what we saw at baseline is a pooling equilibrium where prices and quality are not strongly correlated. Another thing to note is that there are often very few shops in a market. There's sometimes just only one, and they carry several varieties of hybrid maize seed. And only 10% of farmers in our sample at baseline were actually using hybrid maize seed. So we introduce a demand shock by providing a subsidy specifically for the Cacassa hybrid maize seed. And this is randomly provided across communities. And we provided a voucher for the full value of a 1 kilogram bag of maize seed, which is the most popular package size. These vouchers were given out at community meetings that were designed to provide information on the Cacassa product. So the farmers would be given the vouchers, they purchased the maize, and then about a week or two later, we would return to these communities and the farmers would redeem their voucher. So what we're going to do is consider consumer and supplier behavior and quality of inputs on the market. So our empirical specification is really simple, a treatment variable. I will either denote a sample of hybrid maize seed for price and quality, or a household. And there's a market, and in the household data, we do have baseline values of the outcome variable, so we can control for those. And standard errors are clustered at the unit of treatment assignment, which is the market. So let's look at our sort of first stage. So what was the result of providing the vouchers to farmers? Farmers adopted hybrid maize seed. And if we look at the control group mean, this is a really sizable impact in terms of the differences in adoption across treatment and control groups. When we break it down, looking at Cacassa hybrid seeds, which is what the voucher was, Cacassa seeds, which is what the voucher was provided for, we see a lot of adoption there, but not, we don't see any effects on adoption of non-Cacassa hybrid maize seeds, which makes complete sense. So at least that's a good sanity check at first. So given that we see demand and adoption increased, let's now focus on the market level effects. So when we purchased these samples of hybrid maize seed from markets, we very carefully recorded the price that we paid for that specific bag of maize seed. And what we're seeing here is the price per kilogram of a bag of hybrid maize seed. And we also see here pretty decent size effects on the price of these products. And this is the case across the board. I'm very sorry, this is not well labeled. The first column is overall, hybrid maize seed overall in the market. The second column is specifically just for Cacassa maize seeds. And the third one is for non-Cacassa maize seeds. And we see that prices increased overall and that there's no difference between the Cacassa price increase and the non-Cacassa product price increase. So let's now break it down further. Oh my goodness, I am so sorry. It's still too early in the morning for me. These are 4 different specifications with the outcome, where the outcome is the price per kilogram for all types of seed in the hybrid seeds in the market, Cacassa and non-Cacassa. This is where we can break it down. Dan's probably going, oh, Noreen. So in the first row here, this is the impact of the subsidy on non-Cacassa hybrid maize seed products, right? The second line just sort of shows that Cacassa hybrid maize seeds had a higher price in general, right? But what we see here in the third set of coefficients is that we cannot reject that the prices of Cacassa products increased, but also that they increased differentially from the non-Cacassa products. So why do we see that the prices of non-Cacassa products increase? So this is a sort of surprising result at first, but it turns out that it does make sense, and I'll show you why in a couple of slides. So moving on to product quality, and like I said, we measure this as the germination rate, so basically whether a seed sprouts into an actual plant or not. And again, these are results across different specifications for all of the products available in the market. And we do see that the coefficients are positive, and we can't reject that the quality improved by looking at this table. But when we run a Kongangrov-Smirnov test on the equality of the distributions, we do find that there is a significant difference between Cacassa and non-Cacassa, the subsidy group and the non-subsidy group. And that p-value is 0.02. So just to note, we do have sort of small sample sizes here. So we're working on some robustness checks to make sure that this is consistent. So again, next, let's decompose this into Cacassa and non-Cacassa products. And from this first row of coefficients, we see that the subsidy increased the quality, the germination rate of non-Cacassa products. In the second row of results, we see again, just like at the baseline, that Cacassa products are of higher quality than non-Cacassa products. And finally, we have this result again that we can't reject that the quality of Cacassa products improved. We can't reject that they improved differentially compared to the non-Cacassa products. So this is another conundrum. Why did the quality of non-Cacassa products increase, right? So we see an increase in prices and quality for the group of products that did not have a subsidy. Okay, so that's what we want to think about for the rest of the presentation.
Sorry, Noreen, maybe like 4 minutes or so. Is that okay?
Yeah, absolutely. Yeah.
Okay, thanks.
Thank you. So when we think about mechanisms, what we want to think about here is the degree of substitutability between Cacassa and non-Cacassa products and the composition of products that are on the market. So as I mentioned, product assurance schemes allow companies to select in, it's not a mandate, and they select also which of their products that they label. And these products are all available in the same markets and in the same shops. So there can be high quality products that are not tagged and tagged, and sometimes there are products from the same company that are tagged and not tagged, are labeled with Cacassa and are not labeled. And these products are very close substitutes, especially sort of within the same seed company. And if Cacassa products are priced higher, then shops can increase the products that are very close substitutes, right? So why not sell the substitutes at a higher price, because the prices of Cacassa products due to labels and the quality signal are higher, right? And so they don't want to stock the low quality non-Cacassa products. We can't observe what exactly shops did with these. Maybe they hid them in the back and stopped selling them to farmers. But the key point is that because these products are close substitutes, the shop owner can charge a higher price, and they will benefit from that. So what happened with this scheme is that it enabled a separating equilibrium by changing the composition of products available on the market. And so, in this separating equilibrium, we do see that the price and quality of Caucasa maize is higher at N-line compared to the non-Caucasa maize, right? And prices also became more indicative of quality in markets with the subsidies. So the information asymmetry problem here is partly ameliorated. And so even though only some companies decided to signal quality for some of their products, there were spillovers into non-labeled products. And this is where the overall increase in quality in the market is coming, in the quality of products in the market is coming from. Maybe just quickly to look at farmer welfare. Maize yield and farm income actually is reduced in subsidy markets. But we have to note that part of this is going to be because farmers were also purchasing a lot of complementary inputs like herbicide and fertilizer, and they may not have sort of got the mix right immediately. So, overall, subsidy for product assured hybrid maize seed increased demand, prices, and quality. And so the important thing here is that it allowed for experience, but also learning about quality of the products. And this had quite big spillover effects across the market. And the spillover here was specifically due to the substitutability between products, driving out and changing the composition of the products available overall in the market. And so the scheme helped move the hybrid maize products from a credence good to more of an experience good, where you can't observe quality necessarily very well ex ante, but you have a much better signal of quality ex post. And this is a specific feature of product assurance, and this may be more cost effective, because if you think about quality standards and quality mandates, someone actually does have to pay to get these products tested. And it's, as we learned, quite expensive to do so. And so it might be beneficial to just let the high quality firms select in, models of product assurance and labeling. That's what they predict. And that is what we saw here. So our results show that in credence good markets, input subsidies would benefit from linkages to quality signaling. And I'll stop there. Thanks.
Thank you so much, Noreen. That was awesome. Lauren Bergquist from the University of Michigan is going to discuss.
Great, and I know we're short on time, so I might keep it a little bit short, but I will send you all of the slides, Noreen. So thanks for a really great presentation, and thanks to you and Dan for a great paper. I wanted to start by saying sort of why this is both an incredibly important problem and also a really interesting, why product assurance is a really interesting solution. So these issues of low quality products, are widespread, and that's true not just, I want to emphasize, for agricultural inputs, but also for agricultural outputs. So issues like, for example, aflatoxin, low quality maize being produced for consumption. You see this issue in the health sector, so fraudulent malaria medication. So this is a really widespread issue, even above and beyond agricultural inputs. And of course, what are the problems from low quality products? Well, first, of course, the products themselves can then be either sort of at best ineffective, at worst harmful, and it has this potential knock-on effect of limiting learning and take up of what would otherwise, if they were authentic products, be potentially very useful, right? So this has been, I think, studied in the case that Noreen's looking at, of thinking about sort of adulterated fertilizer and hybrid seeds. Okay, so what are some potential policy solutions? There's been some attempts to study, for example, the entry of higher quality competitors. Does that seem to increase the quality that incumbents are offering? Testing of the actual quality of the product itself to allow for branding or government regulation. And then what Noreen and Dan are testing is something that's quite new, which is this idea of product assurance, right? So it's saying it's not actually testing the physical composition of the product, but it's saying, is this kind of an authentic product produced by the manufacturer that you think produced it? So that has implications, I think, for where you should see it correct quality problems depending on where they're happening along the chain, but it's a really interesting and new potential solution to this problem. So I think for the sake of time, I'll skip over results. Noreen did a great job describing those and just jump into my comments. So first, I think, one important comment I had, which is also just a point of interest of mine and then a request for more information, is sort of where does quality falter along the supply chain? So it seems to me like product assurances are most useful when either adulteration or sort of fabrication is happening further down the supply chain. So if it's just the manufacturers producing low quality hybrid, this isn't going to solve that, right? It's putting a label on there. It says this comes from the real manufacturer you think it came from. And if they're producing low quality, that doesn't help much. But if it's, say, intermediaries, traders along the supply chain, or it's the final retailer who's doing adulteration or fabrication, this could be really useful. So I think it'd be useful to sort of clarify where along the supply chain things are going wrong. I assume in your case, it's probably at the sort of retail or at least further down the manufacturer side. One, because again, product assurances are most useful in that setting. And two, the variation that you're inducing experimentally is at that community level. Right? But I think it'd be really neat if you have any data, you seem to have some data on manufacturers to say sort of where along the supply chain is the quality faltering. That might help guide policymakers about which sort of intervention or policy you want to adopt. The second point is just understanding the experimental shock. So I think, Noreen, you clarified this really well, I think, or highlighted this well in your talk, but I just want to emphasize, what's randomized here is not the CACASA program itself, but it's a subsidy for CACASA products, right? So it's like a demand shock for these branded products. And so I think it'd be useful to spell out really concretely, the theory of change of what the marginal effect of the subsidy should be. So just one example, maybe it's the case that CACASA reduces adulteration, but of course that program is active in both your control and treatment areas, so that can't explain the difference you see. But maybe farmers are stuck in some bad equilibrium, they assume it's bad quality since it's always has been bad quality, and so they don't buy it, except for when you subsidize, right? And then once they try it once, they sort of learn it's good and that can get you out of that equilibrium. So that's one possible theory of change. Now, I will notice to kind of critique my own hypothesis here. I think given the really valid point you mentioned at the beginning of it being hard to learn, one might wonder how much is a one-time, if it's difficult ex post to observe the quality of hybrid, even if you're subsidizing a one-time purchase of high quality, will farmers know it's high quality, right? So I think that's worth sort of sorting out. I think you do want to argue against a potential alternative story of, maybe this is just generally encouraging experimentation of hybrid seeds more generally. Maybe it has nothing to do with kind of the branding. So consistent with this, it does look like the demand shock for CACASA is not much larger than non-CACASA. Just to return to these results, you do see the significant effects only for CACASA and not for non-CACASA, but they're both positive and they're not that different. I mean, I'd be curious to know, are they statistically different? I thought also it'd be interesting if you have any high frequency data. One hypothesis I had is maybe someone goes and buys this subsidized CACASA hybrid, but doesn't pay attention to the branding and then goes back and buys any kind of hybrid the next time. So if you had data on sort of the timing of demand, that could be sort of interesting. I also was curious in the intensive margin here, what those results look like. I think this is just the extensive margin. And so consistent with being a demand shock, maybe it's not surprising that prices go up, et cetera. Okay, the third comment is on incentive to quality upgrade for non-CACASA. So this is a really interesting result. I think it's one of the most interesting results you have. Why should quality upgrading happen for non-CACASA? And I wanted to just deepen the puzzle by noting that if you take, again, I'm pushing you to take the point estimates seriously when they're not significant. So people have different opinions about how seriously to take this, but just if we take the point estimates seriously, it looks like we see not only an increase for non-CACASA, but in fact, we only see an increase for non-CACASA. So just look at the magnitude of these interaction terms, right? They're totally offsetting the voucher effect. And so it looks like what you're seeing is an increase in quality for non-CACASA and not for CACASA, which is pretty, I think, in some ways surprising. Now, maybe CACASA already works so well that there just is no adulteration in CACASA. And so all that remains is a chance to upgrade for non-CACASA. But then there's still that puzzle of why non-CACASA upgrades. I think you pose one nice solution. I just would have wanted to know more about the incentives the retailer has, things like markups for different brands and that sort of thing here. Finally, farmer welfare effects. So, these I think are a little surprising. So you see these negative net farm income effects. You mentioned it could be because prices and input use is going up, which means costs are going up. So net income or profits are potentially going down. It still raises this question though, of like, is hybrid a good idea for these farmers then? Are they making a mistake in using hybrid? What's happening there? And then moreover, of course, there's this surprising effect on yields, which can't be explained by prices. So I think it's worth just trying to dive into and understand. So I'll conclude, I think, just possible extensions. One is, I already mentioned, again, this is my personal bias from my own research, but figuring out where quality goes wrong along the supply chain, I think is really interesting here, and you might be able to shed some very interesting light. Second, this issue about kind of short-term subsidies. So the rationale for short-term subsidization is often about this idea of experimenting and learning, but as you sort of nicely highlighted in your intro, that can be very difficult when it's hard to learn about the quality because other factors kind of muddy the signal. But then there's the question of how does a one-time subsidy here, even of high quality, promote that learning? So I don't know, again, if you have high frequency data, maybe you can say something on that. And then finally, just, classic kind of question in the subsidy literature is thinking about if there is learning happening, are there potentially spillovers to other people, sort of all of this recent Carter et al. Piece in AEJ Applied. So I'll stop there. Really interesting paper, super important topic. Thanks so much.
Thanks so much for the comments. Can I just share one really exciting thing is that we now do have high frequency data because we phoned the same farmers in the sample, and in the voucher villages, they're still using Cacasa products more, which is great.
Very cool.
Well, I didn't see any other questions come up, and we've hit time by -8 minutes, so that of course demonstrates my weakness as a timekeeper. But this was a really fun session. I think we saw 3 fantastic papers that demonstrated some of the really neat things that are being looked at now with RCTs at the intersection of sort of development and agriculture. So thanks to all the speakers and the discussants. Although early in the morning East Coast time, this was really fun. So I appreciate everybody's effort here. This was awesome.
Thanks, Kyle.
Yeah,
Thanks. Kyle and
everybody.
Karen, thanks very much
Thank
for
you.
organizing.
Yep, thanks everybody.
Thanks, everybody.
Thank you so much.
Bye.
Bye.